This is Pre-Calc 5.5 Law of Sines, and you'll see on your paper already that the Law of Sines is printed out for you, and most of you have seen this before, but it's a proportion where we compare the side of an angle to the side opposite that angle. That ratio is always the same as another sine of another angle compared to its side length. Now you'll see all three of them. There's sine of A over A equals sine of B over B equals sine over C, sine of C over C. You'll see all three of them together, but you will only ever use two of them at once. So you'll never use all three at the same time. When do we actually use the law of sines? Well, we usually use it generally when we know an angle and the side opposite that angle. If you're looking for something else in particular, law of sines can handle it. So, for instance, if I knew angle A and I knew side length A, and either another angle or another side, then I'm good to go. I just need three of the four pieces to be able to solve it. So generally speaking, look to see if you have an angle and the side across from it, and then you're going to be using the law of sines. Okay, so here's how we use the law of sines. Notice that I have angle A, 120 degrees, and I have the side across from it is 10.45. So that's my starting point. So I will be doing the sine of 120 degrees over 10.45, and that will be equal to the sine of angle C over 8.25. Obviously, I did not choose anything with angle B because I don't know angle B and I don't know side B. It's too much unknown. So I'll start here with angle C. Since it's a proportion, I'm going to cross multiply as a quicker way of solving this. So I have 10.45 times the sine of angle C is 8.25 times the sine of 120 degrees. So my next step, I have the sine of angle C is 8.25 times the sine of 120 degrees, and I divide by 10.45. Now when you type that right side into your calculator, you're going to have a decimal, and that's the sine of your angle. Therefore, you're going to use your calculator to calculate angle C for you by asking it what angle is it that has that sine value. So you'll take the decimal that you just got from that fraction on the right hand side, input it into the inverse sign, and you should end up, as long as you're in degree mode, and we'll be in degree mode this whole time, 43.1 degrees for angle C. Alright, so now if we have angle C is 43.1, that means that we can find angle B. So we already found that this one was 43.1 degrees, and now we're going to find out what angle B is simply by taking 180 minus 43.1 and subtract 120 degrees, and we end up with angle B being just 16.9 degrees. So this one is 16.9. Okay, so the only thing that we have left to figure out is, what is side length B? Well, we can use our law of sines again, and I'm going to go back and use this again. I'm going to avoid using angle C because I rounded that in my calculator to the nearest tenth. Anytime you can avoid using rounded answers, do it. So I'm going to go back to angle A, and I'm going to take that information, the sine of 120 degrees over 10.45 equals the sine now I'm looking at angle B, so that's 16.9 degrees. And across from that will be my side B. And when I cross multiply and solve that, I'm going to trust that you know how to do that. And should get here that B is about 3.5 if you round to the nearest tenth. So I want you to notice something up here on the triangle. Where we have the largest angle, angle A, it is across from the longest side. 10.45 is bigger than both 3.5 and 8.25. So 8.25 is kind of our middle-sized angle, or middle-sized length. It is across from our middle-sized angle. 43 is between 120 and 16.9. And then, of course, our smallest angle is across from our shortest side. And we'll always work like that. And you should always double check that that is indeed the case when you get done solving a triangle. Okay, so there's our first triangle done with law of sines. Okay, let's look at an application. Person has a kite out on 1,750 feet of string. So here's my kite. It's out on 1,750 feet of string at an angle of 75 degrees with the ground. Okay, so here's the ground, and it's making 75 degrees. Now, an observer notes that the angle formed by the kite and the flyer, so here's the flyer, here's the observer, someone watching the person that's flying the kite. That angle formed by the kite and the flyer, sorry, I'm getting lost in here, is 102 degrees. So angle formed by the kite and the flyer is 102 degrees. So it's the angle between the kite and the flyer, that's 102. Well, you can see we have an obtuse triangle. We're using Newton's law of sines. We need to find out how far is the kite from the observer. That would be this side over here. So we're going to do the sine of 102 degrees over 1750 equals the sine of 75 degrees over d. So we cross multiply. D times the sine of 102 degrees, 1750 times the sine of 75 degrees, and we divide both sides by the sine of 102, and we will have that D is approximately 1,728.1 feet. And that seems reasonable because the 75 degree angle is smaller than the 102 degree angle. Therefore, the side that we are looking for, which is opposite 75, will be shorter than the length of the string for the kite, which is across from the 102.